Okay, this is the law of sines proof video. We are going to prove the law of sines. As you can see, we have two cases, an acute triangle and an obtuse triangle. Notice the law of sines works with non-right triangles, so they are both non-right triangles. They're already labeled with the side opposite an angle using the lowercase letter. Okay, so side opposite angle B is lowercase b. Side opposite angle C is lowercase c. And the side opposite lowercase a, the side opposite angle A is lowercase a. So we will prove the law of sines for the acute triangle in this video. First off, you will need to draw in a height. And I just perfectly drew that height in. And the beauty of the law of sines proof is we're just using basic trig identities. So I'm going to start with angle B. And notice when we drew in the height, we created a right triangle on this side, where H is now a leg of the right triangle, and C is the hypotenuse of that right triangle. So sine of B, by our SOHCAHTOA definition, would be opposite H over hypotenuse C. And we're going to go ahead and solve this equation for H by multiplying both sides by C. So we get side C times sine of angle B equals the height. If we do the same thing for the other side, okay, here's our right triangle. Here's one leg, here's the other, here's the hypotenuse. Okay, so H is again a leg of the right triangle, and B is the hypotenuse. So we can set up the same thing. Sine of angle C has to equal opposite over hypotenuse. Doing the same thing we did before, multiply both sides by side B. We get B times side B times sine of angle C equals H, the height. So here we have two expressions, both equal to H. So if they're both equal to the same height in the acute triangle, then they have to be equal to each other. So I'm going to take C sine angle B equals B side B sine angle C. And from here, I am going to divide both sides by sine angle B times sine angle C. So trig equations are just like any other algebraic equation. You can divide both sides by the same thing, as long as they're not equal to 0. And when I do that, on the left side, sine B cancels. So I'm left with C over sine of angle C. On the right-hand side, sine of angle C cancels. So I am left with B, side B, divided by sine of angle B. And that is one part of our law of sines. Now, to get the third angle, okay, I would need to rotate this triangle. And I'm going to go ahead and do that for this proof. Let me extend page, redraw the triangle. That was quick. Okay, just to make it look similar, I'm going to rotate this triangle on its side. Okay, so all the letters, it's the exact same triangle. And we have A, B, C. Okay, exact same triangle, they're in the exact same spots. All we did was rotate the triangle. Okay, so we're going to draw in a height. We're going to drop a height down. I'm just going to steal this one again. And unlock it. And let's see if this works. Okay, this works. Just extending it. Unlock it back up. Okay, so there's my new triangle. Actually the same triangle, just rotated. And for when we drew in that height, notice we created a right triangle where again, here's a leg, the height is a leg, and side B is the hypotenuse. Okay, so if we take sine of angle A, it will again equal opposite the height over the hypotenuse, side B. Do the same thing on the other side. Angle B, so sine of angle B equals opposite, which is the height again, over the hypotenuse, which in this case is side A. Once again, we will multiply by our denominators. So this side we get B sine of angle A equals the height. On the right hand side we get A times sine of B equals the height. And once again, this height is the same length for both equations. So therefore, if B sine A equals the height and A sine B equals the height, then B sine A has to equal A sine angle B. Doing the same step we did before, divide both sides by sine of A times sine of B. Sine of A, sine of B. We can once again, on the left hand side, cancel out sine of angle A, and we're left with B over sine of angle B equals this side, sine of B cancels with sine of B, side A divided by sine of angle A. And notice those are equal. And since we use the same triangle, B is still the same length, angle B is still the same measure. Okay, we can combine that with the one we did before. So if B over sine of B, sine of angle B equals C, side C over sine of angle C, all three of these have to be equal, and there's your law of sines. In the next video, we will prove it works for obtuse triangles as well. However, if you want to take a moment and try it on your own first, and then you could use the video to check your work. I will be back in a moment.